Hey guys, today we will be talking about solving multivariable equations. We're just going to look at the very basic level, some basic problems. We'll get into more complex problems with more variables later on, but today I just want to focus mainly on two variables. How can we get the variables apart from one another? So let's just look at how do we even solve equations to begin with. So this first problem I have, it's not multivariable because we only have the variable x that we're trying to solve for, but it'll at least give us a good idea of what we're doing for solving this. So if we get ready to solve this, we'll draw our line down from the equal sign, and our goal is to get this x value all by itself. So we are going to try to undo all of the stuff that is happening currently to x. So the first thing that we can undo is we can undo this subtract 5 by adding 5 to both sides so that it cancels out on our left side. So we are left with 2x equals, and then 7 plus 5 will give us 12. Now we need to undo the multiplication of 2 to x. So in order to undo that multiplication, we are going to divide both sides by 2. So we are finally left with x equals 6 as our final answer. So when we're solving equations for one variable, we expect to get a single numerical value for an answer. However, when we go to solve multivariable problems, we are going to still have a variable in our answer. So it's almost like we're rewriting the equation. So just make sure that when you're solving multivariable equations, you're not expected to get a single number. You're expected to get an equation. So you're just rewriting the equation in a different form. So let's take a look at the second example. We have 2x plus 3y equals 12. I know this is a multivariable problem because I have two different variables, x and y. So for this problem, let's go ahead. We will solve for y. And this is a good example of a problem where if we have a linear equation and you want to graph the equation, we typically like that equation to be in y equals mx plus b form, so your slope-intercept form. Well, when it's like this, we don't know what our slope is and we don't know what our y-intercept is. So we can rewrite the equation to get y all by itself so that it is in y equals mx plus b form. So just like we did on the last problem, we want to look to see if there's anything we can add or subtract to the other side to get this y variable all by itself. So I do have this term right here, this 2x term, that I can bring to the other side. Because it's currently a positive 2x, I'm going to want to subtract 2x from both sides of my equation. So this cancels out on the left side. I still have a 3y, and that equals negative 2x plus 12. I cannot actually combine those two terms because they're not like terms. So I do have to keep those as separate terms. Now if we look at our y value, it's still being multiplied by 3. So I'm going to have to divide by 3 to cancel that out. And that means I have to divide every single term by 3. So I'm going to divide my first term by 3 and divide my second term by 3. On the left side, my 3's cancel out, so I'm left with a y. And on the right side, I am left with negative 2/3 x, because I can't actually fully divide 2 by 3, plus 4 divided by 3 is going to give me 4. So now I have successfully rewritten my equation where the y variable is all by itself. So this is how we're going to want to solve multivariable equations. However, before we get going on our next example, let's go ahead and do the joke of the video. All right, just remember, for the joke, you are going to write what you think the answer is, and then when you are finished with the notes, you'll come up and show me, and I will tell you if you have the correct answer to the joke or not, and I'll let you know what the correct answer is. So the joke today is, why does a seagull fly over the sea? So go ahead and see if you can figure out that one. All right, let's go ahead and look at one final example of some things you might see as we're solving multivariable equations. So for this problem, we have m equals 4n plus 3, and let's go ahead and solve for n. So if you see, the equation that we're actually already given is solved for m, since our m variable is by itself. But now let's see if we can get this n variable all by itself. So we'll go ahead and draw our line down. Just make sure whatever you do to one side of the equation, we have to do to the other side of the equation. So in order to get this n value by itself, we're going to need to start by subtracting 3 from both sides of our equation. So this cancels out on the right side, and we're left with 4n. And on the left side, because those are not like terms, I can't actually combine them, but I still can subtract them from one another. So I still have m minus 3 equals 4n. And now finally, to get the n all by itself, I'm going to divide both sides by 4. And remember, when we're dividing, we are dividing every single part on both sides. So on the right side, our 4's cancel out and we are left with n. On the left side, not only are we dividing m by 4, but we're also dividing negative 3 by 4. However, instead of writing two fractions, we can just write this as one large fraction with m minus 3 all over 4. And this is our final answer for solving for n.